Welcome to SolidCAM Professor. I'm Sydney, your SolidCAM Professor, with one of many videos available to you 24 hours a day, 7 days a week. In this recording, we'll illustrate the use of several SolidCAM high-speed surface machining strategies, otherwise known as HSS, to machine the base part as shown on our screen. First, I'd like to mill out these fillets on the part around over here, on this side as well as on the flip side. And to do this, I'll be using the option of engraving. If I were to open up the operation, you can see we use the option of projection in HSS, which is what we use for engraving in HSS. The geometry itself, in this case, if we take a look at the face itself, is this face over here. And the projection curve itself is this curve over here. Now, the end mill that we'll be using will be a ball end mill of 10 millimeters, which is also the radius of this particular surface over there. And if we go into our transformation area, we have depth cuts. In our depth cuts, we're going to have it go down 3 times of a spacing of 1 millimeter between each pass. Taking a look at the simulation of the part itself, now do this one step at a time. You can see the tool going down, and it went down in 3 steps on that projected curve as shown over here. The same is true with the next 3 operations, doing it on the flip side over here, and on these 2 operations here as well, doing it on these curves over here, on this radius and on this radius. In our next 2 operations, I'd like to machine out this surface over here as well as these surfaces over here. So for that, I've used the option of morphing machining. This strategy is utilized to generate a tool path evenly distributed between the fillet boundaries. So if I were to machine this area, if I were to open up the operation itself, you can take a look at the geometry itself. The face that I want to machine are these faces over here. And the start edge curve will be this curve over here to start from here. And the end edge curve will be the one at the bottom. And it'll evenly distribute the cuts between these 2 curves on that surface. What we've also done here is made sure that we don't touch any of the surrounding surfaces, and that's done by gouge checking. If we were to go into our gouge check, you can see that we've chosen the following surfaces to make sure that the tool will not touch or gouge any of those surfaces. The tool in this case will also be a 10 millimeter ball end mill. If we were to take a look at the simulation, you'll see that the tool will go down, go back and forth on the surface according to these 2 shapes, the top curve and the end curve over there, and does not touch any of the surfaces on the side. Taking a better look at the Solid Verify simulation, you can see again the tool goes down onto the surface, and it does not touch any of those surfaces on the side. That is because it's being protected by the gouge check. The same, by the way, is done in the next operation, doing it on the opposite side as shown over here. In my next operation, I like to mill out this floor over here. Now, the way I'll do this is by using the option of parallel to curve. We'll be working on this surface over here, as shown in my geometry, and the curve that I'll be working parallel to is actually this curve going around the part. So the tool path being parallel to those lines over there will actually be in a pocket form on that surface over there. I'll be using a 10 millimeter ball end mill, and if we take a look at the simulation, you'll see that the tool goes down and works just like a pocket on that floor, working always parallel to those edges over there, going around the entire surface. Next, I like to machine these external radiuses over here. For that, we use the option of morphing between two curves. This operation actually performs the machining of the external fillets and an inclined face adjacent to the fillet as well. Now, since I'm using the option of morph between two curves, what will actually happen that it'll actually evenly distribute the cuts between all of these surfaces. If we were to open up the operation itself, you can see that my drive surface are these surfaces as shown over here, and my start edge is the edge on top, and the end edge is the edge on the bottom. So it'll actually be evenly distributed between these two edges, the top one over here, the bottom one over here, working on these surfaces. The tool that I will be using will be a 6mm ball end mill. Taking a look at the simulation itself, you'll see that the tool works exactly on those surfaces, evenly distributing the cuts, making for a nice and even smooth cut around that fillet. For more videos on SolidCAM Professor, please go to our website, www.solidcam.com, and look for the tab called SolidCAM Professor. Thank you for joining us on SolidCAM Professor. Take care and have a nice day.